Let's start with the problem description. You have two linked lists representing two non-negative integers. Each node in the linked list contains a single digit, and the digits are stored in reverse order. You need to add the two numbers represented by these linked lists and return a result as a new linked list. Doesn't this remind you of anything? This linked list additional algorithm essentially mimics mutual column addition processing code. Each node in the linked list represents a single digit, and the algorithm iterates through both lists simultaneously, adding the corresponding digits and handling carries just like manual addition. Let's proceed with an algorithm. The first step is initializing. Let's create the following variables. Carry. This variable tracks any leftover values from adding digits in previous steps. It starts at 0 because there is no carry initially. As the algorithm adds digits, any numbers greater than or equal to 10 needs to be split into its single-digit component. This correctly represents the sum 6 and 4, that is 10. The reason we split 10 into its single-digit components. Carry over the 1 and write down the 0 in the first position. The second variable is head. This variable is a reference to the initial node of the result linked list. Since the algorithm builds the list incrementally, starting with an empty node allows the construction to begin. The actual values are added as a new node, forming the result linked list representing the sum. The last variable is result tail. As new nodes are created with calculated digits, previous is updated to point to the last added node. This variable is a pointer that initially points to the head node, empty. This allows the algorithm to eventually append new nodes to the end of the growing result list during each iteration. After initializing, iterate through the list while at least one of the input list has unprocessed nodes, or there is a carry. Let's describe all conditions in more detail. List1.next is not null. This means the next element in the first list exists. If the first element has no more elements, then there are no more digits to add from that list. The second condition is list2.next not null. This means the next element in the second list exists. Similar to the first condition, if the second list is empty, it has no more digit to contribute. And the last condition is carry not null. This means there is a carry digit from a previous addition. Even if both lists are empty, if there is a carry from the previous step, it still needs to be processed and added to the result. Consider adding two numbers where the last digit in their respective list are 8 and 8. Adding this digit results in 16, which is greater than or equal to 10. In this case, we need to split the sum, append the last digit 6 to the result list as a new node, carry over the first digit 1 to the next step. Let's start our iteration through the list. The first operation is extract digits. Get the values from the current nodes of both lists, if they exist, otherwise use 0. Calculate sum and carry. Add the values from both lists and the carry, updating the carry if the sum is greater than or equal to 10. Our sum is 7, so there is no carry for the first iteration. The next step is create new node. Create a new node with the value equal to the last digit of the sum. Reminder after dividing by 10. In our case, the remainder of 7 after dividing by 10 is 7, and it's our first result node. The next step of iteration is append to the result. Add the new node to the end of the result list and update the pointer for the next iteration. In the second iteration, we move on to the next digit in each list. From list 1 we take the digit 4, from list 2 we take the digit 6. The carry is 0 from the previous step. Adding 4 and 6 gives us 10. Since 10 is greater than 9, we need to handle a carry over. We carry over 1 to the next column. Next, we create a new node with the value 0 representing the last digit of 10. The result list now becomes 7 followed by 0. In the third iteration, we move on to the next digit in each list. From list 1 we take the digit 3. From list 2 we take the digit 4. The carry from the previous step is 1. Adding 3, 4 and the carry over of 1 gives us 8. Since 8 is less than 10, no carry over is needed. We create a new node with the value 8. The current result list becomes 708. Recheck the condition. Let's recheck our condition. The next element in the first list doesn't exist. The next element in the second list doesn't exist as well, so no more digits to contribute. There is no carry digit from a previous addition. So our result list is ready as all conditions are false. And the last step is return result. Return the remainder list which represents the sum of the two input numbers. The algorithm is completed, so let's code it. I have created test data in main function to debug it in the further step. Let's initialize variables to track the carry and the head of the result list. Iterate through the lists until both are exhausted and there is no carry left. Get the current value from the first list, or use 0 if it's not exist. Get the current value from the second list, and prepare a list for the next iteration step. Calculate the sum and update the carry. Prepare a new node for the sum and append it to the result list. After the end of iteration, return the head of the result list, excluding the dummy head node. And rename variables to result tail, as we described in the algorithm. Let's debug it. There is some error. Let's try to fix it. Maybe brackets. Let's rerun it. No, the problem is here. Let's debug it again. 6 plus 5 is 11, so we should split it into two components. Sum will be 11, and we create node with 1 and carry is 1. Okay. Second iteration. Let's check that sum will be updated with carry from the previous step. Yeah, and we append new node to result list. The third iteration. The sum is 10, the carry is 1, and Yeah. We append new nodes to the head. And in the end, we have correct answer. The first node is 0. We should skip it. And yeah, let's copy it and paste to the LeetCode. Run. All tests was passed successfully. Submit our solution. Yeah, good.